Hi guys, today I will teach you the Kirchhoff Current Law and the Kirchhoff Voltage Law and the calculations you can do. So let's start it. So the circuits are composed by nodes, this over here and this over here, and branches. I will talk to this later, but we have nodes, that is this, and this, and this. Let me remove this, and this, and this. These are nodes, okay? And we know that the sum of the current who enter or leaves the node needs to be equals to 0. So let me show you. This current plus this current plus this current plus this current needs to be 0. Okay? They are all entered on the node, and the sum of that needs to be 0. You can do it by leaving, needs to be 0 too. The sum of these were leaving. But I will analyze it. So I will call this current I1, this I2, this I3, and this I4. And I know that I1 plus I2 plus I3 plus I4 is equal to 0. We know the Ohm's law, that is voltage equals to current multiplied by the resistance. So we know that the current is equal to voltage divided by the resistance. So let's go calculate the I1. We can't, because we have no resistance, right? We just have the voltage drop of this power supply, so we can't calculate it. But we can calculate I2, I3 and I4, right? We have the resistance R1, R2 and R3. So let's do it. Let me call this node V1 and this V2. You can call it whatever you want. You can put this one node to ground. Let me say that this is ground. I can put it to ground. It's my choice. Okay. We can put this. You put whatever you want to ground. One of them can be ground. So let's do this. We know that I2 it's equal to 0, because this is ground, minus V1 divided by R1. And you know that R3 it's equal to 0 minus V1 divided by R2, and you know that I4 it's equal to 0 minus V1 divided by the R3. So let's put these expressions over here. Let me just simplify this. Note that the I1 it's equal to minus I2 minus R3 minus I4. It's the same, but because we will calculate I1, because we don't know, we can calculate it directly. I will put it into here. So let's calculate. I1 is equal to, we know that I2 is equal to minus V1, so it's minus V1 divided by R1 minus V1 divided by R2, that is I3, and minus V1 divided by R3. This is I2, this is I3, and this is I4, right? So let me do this. We know that I1 it's equal to V1, and what is the value of V1? Here we have a power supply of 250 volts. Here you know that is 0 volts because it's ground, and you know that this voltage drop is 250 volts. So you know that V1 minus 0, because this is 0, this is ground, it's equal to 250 volts. Okay? So we know that V1 it's equal to 250 volts. So let me come over here and say that 250 divided by R1, that is 5K, plus 250 divided by 20K, plus 250 divided by 8K, this will give the value of I1. If you put this on the calculator, it will give you 93.75 milliamps. Because it's in milliamps, because this is K, this is kilo ohms. Okay, if we put this to ohms, we need to multiply 10. So this will be 93.75 times 10 power of 3 amps. Easy, right? And now I will challenge you to do this, analyze this circuit with the Kirchhoff Current Law by your own. It will be difficult, but I will give you some tips, okay? You have 1 node, 2 nodes, 3 nodes, 4 nodes. I can give you the names for you. You have here V1, V2, V3, and you can put one node as a ground, so I'll put this one over here, because it's more easy because of this power supply, because of this voltage drop. Okay, if you put here, let's say V4, you need to make V4 plus this will be this, and in this way it's easier. Okay, you know that this voltage drop is V, because this is 0, and so this is V, so over here it's V, and yeah, you need to analyze this. Try. If you are a beginner, it will be difficult, but it's a very good exercise to understand the Kirchhoff Current Law. Thanks for watching, guys. I'll see you on the next class.